Hey everybody, here we are for day 2 of Advent to Code 2015. Again, I thought I'd just go through these um, one day at a time, see if we can't solve them. Yesterday's was pretty easy, but maybe we can have a more interesting one today. Although, if I remember right, the first years were simpler, though I may be eating those words. Anyway, I'd love to see your solutions. I'm going to post links below to like a gist that you're welcome to you know put your solutions in, and we can chat about them in the gists or obviously down below in the comments. So um, just keep that in mind. I'd love to see what you're doing trying to solve it. Again, we're trying to flex some of our mental muscles, see if we can't get ready for the upcoming Advent to Code in a couple months, or maybe you're watching this well into the future, and you just want to stay up on your problem solving, puzzle solving skills. So here we go. Let's do it. It is day 2. I was told there would be no math. The elves are running low on wrapping paper, and so they need to submit an order for more. They have a list of dimensions: length L, width W, and height H of each present, and only want to order exactly as much as they need. Okay, this one could be tough. I think there's like a placement problem, like how do you place shapes to like minimize the area? Anyway, we'll see. Uh Fortunately, every present is a box, a perfect rectangular prism, which makes calculating the required wrapping paper for each gift a little easier. Find the surface area of the box, which is 2 length times width, 2 width times height, and 2 height times length, or the sum of those three. The elves also need a little extra paper for each president. The area of the smallest side. Okay, so one of these sides is like the smallest, and that's the additional paper they need. For example, a present with dimensions 2 by 3 by 4 requires 2 times 6, 2 times 12, and then 2 times 8. Yeah, okay. Square feet of wrapping paper plus 6 square feet of slack for a total of 58 square feet. Because 2 times 3 is the smallest one. Yeah, so 6. Uh, okay. Uh, like we can pull out the 2's, right? So we can do 6 plus 12 plus 8 and then times them all by 2. So we just find the smallest area. A present with dimensions 1 by 1 by 10 requires 2 times 1 plus 2 times 10 plus 2 times 10. 42 square feet of wrapping paper plus 1 square foot of slack for a total of 43 square feet. Yeah, this is the smallest one. Okay. All numbers in the elves list are in feet. How many total square feet of wrapping paper should they order? Okay. I mean, this isn't nearly as tough as I just thought it'd be. Like I said, there's one problem where it's like a how do you fit all the boxes into the least amount of area? It's a problem I've seen before somewhere. I don't remember where I saw it, but these numbers. So basically, I'm just going to get this, and I'm going to have 3 digits. I'm going to want to break them up and then do some math on each one of them, which is these right here. So we'll do this, A times B, A times C, and B times C. And the smallest of that will add to those. Smallest of those 3 will add to here. Okay, I think I grabbed my puzzle input already as well. Yeah. So we can put this off to the side just so we can see what it looks like a little bit while we're trying to solve it. Um, Okay, so I think the first step is, I mean, we can probably do this functionally. We'll take the lines of each one, and then we want to do a map. And within the map, we want to split by X. Is there a split care? Oh, it says it can be a car. So we just do split on X. This is probably not super efficient, but now we have our 3 parts. And so we can say let parts equal, what is it like here? Ooh, I can actually map it right here. N dot parse dot unwrap. And so we'll say these are, I don't know, U size. Okay, what doesn't it like? Cannot be built from an type. Oh, from it's not implemented for U size. Returns an iterator over substrings of the string slicer for characters by match pattern. Am I just missing this? Maybe I can't do it this way. This is where AI would probably be nice. It's a little annoying that I can't do these together. Am I? Oh no, not that way. This way. Oh, okay, it does work. I must have had something wrong there. Okay. So we'll just say, so we have our 3 parts. We'll assume we get 3, and then we want to do. So we'll say let A B equal parts 0 times parts 1. Let AC equal parts 1 times parts 2. Actually, that's BC. Let AC equal parts 0 times parts 2. And then we'll return the sum of those times 2, so it'll be 2 times AB plus BC plus AC, and then plus something like that. So for each of those, we're going to produce that, and then we're going to sum them all up. So this is actually going to be a U size, I guess. Why would this, oh, the old semicolon at the end? It is sometimes annoying, right? Like you kind of want to, I mean, this is obviously faster, but I mean, I guess return always works. So you could, if you're just used to working in like C or whatever, it probably just always works. Okay. Oh. Line 77. Oh, line 7. Do I have a? I do have an empty line down here. Okay, let's write a test. I'm probably doing something wrong. Let's see what they use. We'll do 2 by 3 by 4. And then 1 by 1 by 10. Oh, that's, I mean, let's try this. My guess is like this is why it's failing. It's got the extra new line at the end. What would it be? 58 plus 43. 101. Rutro, why does that pass? Oh, this still says day 1. Okay, that might be a bug in my code. Let's see if that does it. It does. Okay. Not too bad. Again, relatively easy. It's just doing some math for part one. Could I make this quicker? I mean, you could potentially use like there's a Cartesian product, and then you could do the product of those. And then there's probably an easier way to do the min here. Anyway, I'd be interested to see how y'all do that. But this feels easy enough to me, right? Basically, we're going through each of the lines and we're mapping over them, and we're splitting by the x's, and we parse them into u sizes. We aren't doing great error handling, right? We're unwrapping here. You know, we could return results and then sum with an error. There's a way for you to like map result type thing, and then sum, so that if any of them error out, the whole thing errors out. This feels good though. I mean, not too bad. Not too shabby for day 2. Okay, part 2. The elves are also running low on ribbon. Ribbon is all the same width, so they only have to worry about the length they need to order, which they would again like to be exact. The ribbon required to wrap a present is the shortest distance around its sides, so the smallest perimeter of any one face. Each present also requires a bow to be made out of the ribbon as well. The feet of ribbon required for the perfect bow is equal to the cubic volume of the present. Don't ask how they tie the bow, although they'll never tell. For example, a present with dimensions 2 by 3 by 4 requires, so these are the two lowest. So that's that part of the perimeter of like the rectangle, right, is the lowest, and so you just sum up the 4 sides. So it's like 2 times 2 plus 3 times 3, and then they want to do the area, which is just 2 times 3 times 4. Give you 34 feet. 1 by 1 by 10. The 2s are the 1s. And then the area is 10. Sorry, the volume. Is it? What did they say? The volume, right? Yeah, cubic feet of volume of the present. Okay. So just now we're doing the same thing. We're just doing 2 different calculations. So this feels like it should be relatively similar. We'll just copy and paste. We can add a test for P2 as well. So in this case, it's going to be 48. Okay. So we're still going to split. And so we'll say let the volume be part 0 times parts 1 times parts 2. And then we want to find the 2 smallest sides. I mean, I feel like it's probably easier just to sort these and pick the first 2. So if we do, this is really dumb, but like you essentially just like, we're looking for the 2 of the smallest, and it's probably fastest just to sort these. I mean, even doing an unstable here this is probably overkill, right? But you know, what can you do? Okay, so we're gonna do eat the two smallest. So we're gonna return 2 times volume plus 2 times parts 0 plus parts 1, right? So we've sorted them. We now have the two smallest at the beginning, and we pick those two. I could probably think about it for a minute. Maybe there's a faster way to do that, but I feel like okay, there you go. Day 2, not too bad. Again, these have been relatively easy. I think anything that you can essentially do in like a for loop and just do a couple calculations are a pretty good easy start, right? This may be tough if it's like you're in a high school level computer science class and it's kind of new to you. But that's okay. I mean, we're all in different places, right? So if you struggle with these, that's fine. We're all trying to learn and pick up. There's some that I don't know the answer to. I'm sure there's going to be some where we're going to be Googling. So, you know, don't be too surprised when we get there. I don't know. What are some optimizations that you might want to do with these? I mean, you definitely still have to do parsing. You could potentially optimize on memory. Again, like instead of collecting right here and then doing this work, you could it's called a product, I think, Cartesian product. Rust iter tools Cartesian product. Yeah, this right here. So if you have these two values and these two values, it like does a product all like this one and this one, this one and this one, this one, this one type thing, right? Although in this case you only have, well, you could do like the first item and then the next two, and that would get you like, so that would be like the really that this may actually not work. Because we're actually talking about like a combination. So it's like Rust. Nope. I actually have a library that does this stuff. I can tell you. I mean, I don't. This one right here. Yeah, I haven't touched it in like a few years, but we do like a, what was I doing with this? I was trying to come up with permutations for a problem, and I thought, oh, I should just write the library. I mean, it works really well, so I've never felt the need to change it. But this is what we're really just looking for is like a set of combinations, right? So you could use this library. Again, it feels a little overkill, right? So you can see here's 3, pick 2. This would produce A, B, B, C, and AC. Like this is exactly what we're looking for. If you create like a new combination, we're only dealing with 3 though, right? And so that's where it feels like, is it really worth using some library to do that? Feels like you could just do this, right? And then the min, you just, you know, pick the min of the 3 and sum them up. Same thing with this one. Again, I mean, the sort is so small. You could probably even say like because you're sorting, it might be easier to say like let first equal parts 0. It'd be like if part 0 less than part 1. So this would get you the smallest of the first two. I guess we could do equal as well. You do some variation of this, right? You'd say if part 0 is less than parts 1 and part 2, else part 1 is less than or equal to part 0 and parts 2, else if parts 2 is less than 0 and 1. You know, now you found the first one and then you like eliminate that first one. I don't know. It's hard to say. The sort is probably overkill, but this feels clean enough to that it works. So let me know how you solved it. Maybe there's a simple way mathematically to find the smallest of 3 digits. You may be able to do some bitwise things. I'd have to think about that. Anyway, that, you know, again, not too tough of a day. So I'd love to see your answers. Again, I'll post the stuff down below in the description, or feel free to comment, tell me what you think about you know, how you solved it, or what might be an easier way to solve it. I'd love to see how you're doing, and again, we'll just keep solving puzzles. So I hope you're doing well wherever, whenever you are, and we'll see you next time.